Hey everybody, Dutch Sense here. 1:41 p.m. Central Time on Saturday, March 1st, 2014. And I've got you over here on the WDSS2.gov page, and we're looking at the streaming radar across the Midwest. Now we have a large snowstorm that's going to be blowing through tonight. It's already blowing through the northern states, Iowa, Nebraska, South Dakota, Minnesota, Wisconsin. And tonight, going into tomorrow, Missouri, Illinois, Indiana, Kansas, this whole area is going to be getting about a foot of snow or maybe just a little bit less. As I was watching all this, here on the unquality control feed, the uncensored feed, you can see something occurring here over Kansas. A series of radar pulses. Now these are targeted beams. These are not harp rings. These are actual targeted pulses that are occurring, and they're centering directly over I-70, right here near Salina, Kansas, right here across the center of Kansas. Now, let me zoom this in first. We've got a beam coming out of Red Cloud, also a beam coming out of Vance Air Force Base, and let's see where the others are coming from. Okay, all the stations actually are pulsing across this center area. Now, this happens from time to time, what we would call a scalar resonance. Each one of these pulses themselves are relatively minor. When they combine, when they cross, at the crossing point, just like Lieutenant Colonel Thomas Bearden said many years ago, where the beams cross, energy can be formed, occur, plasma energy at a distance greater than what's being emitted from the transmitter. It can be modulated up or down with power. Now we're going to go look at these really quick, and we're going to compare the actual signal coming out towards what's happening when they all combine. You see how it goes up into a bright red. Okay? This intensity chart is in decibels of Z. This is loudness, quote unquote, of the signal. You can't hear it. This is all beyond human hearing. But if you could hear it, it would be degrees of loudness of the signal and power. Again, you can see it spike up into bright red. Now, let's go over to College of DuPage here. This is Vance Air Force Base, and we're looking at the last 200 images. And let me just take this down here so you can see the date and time. All right, and when this occurs, you're going to see two light pulses occur. One, and we'll wait for it again. One, two. Each one in the low decibels of Z. And the one that goes up here to the north that you saw turn bright red on the unquality control feed, you'll notice there's less pulses showing up here on the quality control feed. Now the reason they quality control it is to edit out certain things that you would normally see on that we're talking about right now, let's say. It stops people from asking questions. I personally think all radar feeds should be non-quality controlled. You should just be seeing what the radar is seeing, regardless of whether or not it's birds or bugs or an echo from an aircraft. All right, and you can see on this one as well, Grand Hastings at Red Cloud. And here's the date and time. Wait for the pulses. This is the last 200 images, by the way. So you can see the difference. You definitely can see the difference between the quality control feed and unquality control feed when it comes to seeing the intensity of these pulses. Very interesting to see the difference between what all the normal people would see and all the people who actually look into these things see. It explains why a lot of the times people aren't grasping that weather modification is occurring via frequency and it's happening right under their nose. They don't realize that the feed that they're looking at on their regular news station is censored, and that the feed you're looking at on College of DuPage is censored. It really is. Look how they're showing it here. Let me zoom this in again. Let's see if I can. Yeah, okay, it won't let me zoom this in. But just look. It just shows as a very light green, just a couple of them. But you just saw, here's the National Weather Service back-end feed. I mean, it kind of speaks for itself. The feeds do not match, yet they're coming from the same source, which means the public source that most people are viewing is skewed, and that the non-quality control feed is the one you're going to want to consult if you want to see any kind of possible weather modification taking place. So we need to watch central Kansas, I would say, over the next 24 to 48 hours for possible severe weather. Maybe up to 72 hours. Severe weather would be occurring where the scalar resonance is happening. Hope we're wrong, of course, because we've got snow forecast, of course. Let me just quickly show you the areas that are under a watch. There you go. This entire area is under a severe weather watch, and that's severe winter weather. However, we've got damaging winds forming down here to the south and the southwest, coming pointing right towards the center of where those scalar resonances are occurring. Interesting. Watch the area next 72 hours for sure. Central Kansas could be severe winter, could be severe weather. Cheers, folks.